So, hello student. In the series of revision classes, uh, I have started a chapter that has function. I have completed it in the three parts. Now this is the last part of the function. After the completing some important question that are coming comes in your that I have comes in your previous year papers. We have solved next chapter, that was principle of mathematical induction. Okay, so this video consists of both the chapter function and the principle of mathematical induction. In this chapter I will complete all the topics of principle of the function and all the previous year questions of the principle of mathematical induction. And this will be the last video of the mathematical induction and of the math series. I have completed all the syllabus that has done. I have completed all the syllabus that has come in your examination point of view. Now, if you have any doubt, so you can send the question to sir or ma'am. And if you want any live session, so you can tell with sir or ma'am. So I will clear your doubt in that session. Okay. So now the our next question of function is, wait just a minute. Now the next previous year question of your section is, if a equal to 0, comma pi by 6, comma pi by 4, comma pi by 3, comma pi by 2, and f is from a to b, is a surjection. Surjection means it was both 1 1 and on 2, defined by fx is equal to cos x, fx is equal to cos x, then find b, then find b. Okay. Now, what is given in the question? What is given in the question that f is from a to b. F is from a to b. Now, a is the domain and b is the range. And the value of a is 0, comma pi by 6, comma pi by 4, comma pi by 3, comma pi by 2. And function is cos x. Now, put one by one the value of a. First is function is cos x. And the function is cos x. So fx is equal to cos x. Now put one by one the value of a on cos x. So f0 is equal to cos 0 and cos 0 equal to 1. Now next is f pi by 6. That means cos pi by 6, cos 30. Okay. So the value of cos 30 is root 3 by 2. Now next is f pi by 4. F pi by 4 means cos pi by 4. So the value of cos pi by 4 is 1 by root 2. Now next is your f pi by 3. F pi by 3 means cos pi by 3, which is equal to root 3 by 2. And the last one is f pi by 2. So f pi by 2 is cos pi by 2, which is equal to 0. Okay. Now, the values of b are, we get the values of b as 1 root 3 by 2, 1 by root 2, root 3 by 2, and 0. Okay, wait. Now, cos pi by 3 is cos 60, and the cos 60 is 1 upon 2. Okay, sorry, my mistake. So cos pi by 3 is 1 upon 2. So the value of b are 1, comma root 3 by 2, comma 1 by root 2, comma 1 by 2, comma 0. So that was the value of b. Okay. Now the next question is, now the next question is, if f is from R to R, if f is from R to R, comma, g is from R to R, are are defined by fx is equal to 3x minus 1, comma, gx is equal to x square plus 1, then find fog of 2, and second one gof of 2a minus 3. Now see the solution. So what is given? It is given that fx is equal to 3x minus 1 and gx is equal to x square plus 1. Now firstly find the f of gx. F of gx. So f of gx means f of g of x. So f is 3x minus 1 and gx is x square plus 1. Now you have to put the value of x in function fx. Okay. So 3x square plus 1 minus 1. So 3x square plus 3 minus 1. So 3x square plus 2 is the value of f of g of x. Now f of g of 2 is equal to 3 into 2 square plus 2. So 3 into 2 square means 3 4 is 12 plus 2 is equal to 14. So f of gx is equal to 14. Now second is g of fx. G O f of x. So it is equal to g of fx. Now what is the value of fx? So fx is equal to 3x minus 1. So g of 3x minus 1 and the value of gx is x square plus 1. So you have to put 3x minus 1 in place of x. So 3x minus 1 whole square plus 1. So which is equal to 9x square plus 1 minus 6x plus 1, which is equal to 9x square minus 6x plus 2. And we have to find the value of g of f of 2a minus 3. So we have to find the value of g of f of 2a minus 3. G O F of 2a minus 3, which means that in place of x you have to put 2a minus 3. So 9 2a minus 3 whole square minus 6 into 2a minus 3 plus 2. Now open the bracket. So you will get 4a square plus 12 minus um, 4a square plus 9 minus 2 to the 4, 4 3 is 12, 12a minus 6 into 2a minus 3 plus 2. Now open the bracket. So you will get 36a square plus 81 minus 36a minus 12a minus 18 plus 2. So now sum up all this. So 36a square minus 36a minus 12a, which is equal to minus 48a, 81 plus 2, 83, 83 minus 10, 73, and 73 minus 10, which is equal to 81 minus 10, 71, 71 minus 8, 71 minus 8, which is equal to here 62, 63. Okay, so 63 plus 2, 65 will be your answer. Now come to the next question. Once again, check the sign. Plus 81 minus 18 plus 2. Okay. 65. Now the next question is, if fx is equal to 2, if fx equal to 2, gx is equal to x square, hx is equal to 2x for all x belongs to R, then find f of g of h of x. Now see the solution. Firstly, find the g of hx, g of hx, which is equal to g of hx. Okay, so the value of hx is 2x. So g of 2x means you have to find the value of 2x square, which is equal to 4x square. Now find the value of f of g of h of x. Okay, now g of h of x is equal to 4x square. So f 4x square. Now put the value of x. We have fx is equal to 2. So we put any value. So we will get 2. So f of g of h of x is equal to 2. Okay, that was your answer. Now the next question is, now the question is, if f is from q to q is defined by, if f is from q to q is defined by fx is equal to 5x plus 4 for all x belongs to q, show that f is a bijection. F is a bijection and find f inverse. Now what is given? We have given that f is from q to q in rational number to rational number, and the value of fx is equal to 5x plus 4. Now firstly we have to prove it bijection. Okay, means 1 1 and on 2. And if a function is 1 1 and on 2, that means if a function is bijective, then the inverse of a function is exist. Okay, so first is for 1 1 to prove fx as 1 1. So how we can prove fx as 1 1? We will take fx1 is equal to fx2. Now fx1 means 5x1 plus 4 is equal to 5x2 plus 4. Now 4 will be cancelled. So 5x1 equal to 5x2. Okay. So x1 equal to x2 will be your answer. So by taking fx1 equal to fx2, by taking fx1 equal to fx2 for all x1, x2 belongs to q, we have proved that x1 equal to x2, which means that fx is 1 1. So fx is 1 1. Now to prove fx is equal to onto, to prove fx is onto, so what will we have tag? Fx is onto. So let y belongs to q codomain. So if any element belongs to codomain, then there exists x is equal to y minus 4 by 5. Then there exists fx is equal to sorry, wait down. Y belongs to q. Then there exists fx equal to y. So the value of fx is 5x plus 4 equal to y. So you will get 5x is equal to y minus 4. Okay. So the value of x is y minus 4 by y, 5. So you can take any rational number value of y. So you will get q. So for all y belongs to q, there exists x belongs to q, which means the function is onto. That means the fx is onto. Fx is onto. Now, third one, we have to find the f inverse. Now, we know that if function is 1, 1 and onto, then the inverse of function is exist. So fx equal to y. So fx is 5x plus 4 equal to y. So 5x equal to y minus 4 and x is equal to y minus 4 by 5. So f inverse of x is equal to x minus 4 of 4 by 5. That was the answer. Okay. Now the next question is, now come to the short answer type question. The first question is, if f is a real function, if f is a real function, then the domain of then the domain of fx equal to 10x is fx equal to 10x is. So I have taught you that in trigonometry part, that the domain of fx domain of 10x is r minus 2n plus 1 pi by 2. Okay, r minus 2n plus 1 pi by 2. Now they come to next question. Next question is, find the domain of the fx. Find the domain of real valued function fx. Real valued function fx equal to 1 upon 2x minus 1. If that was real, so it does not contain any infinite term. So what we have to do, we have to take 2x minus 1 does not equal to 0. Because if it is equal to 0, then this function will not be equal to real valued function. So 2x minus 1 does not equal to 0. So 2x does not equal to 1. So x does not equal to 1 by 2. Okay. So we will take the domain of the function that x belongs to r minus 1 by 2. Okay. Now come to next question. Find the domain of find the domain of under root 25 minus 6x square. Okay. Now what we take, we will take its at a real value. So for the real value, this term will always greater than equal to 0. So it was always greater than equal to 0. minus 16x square. Huh? That was 16. Okay. So if you take minus common, so minus 25 plus 16x square less than equal to 0. So if you add 25 both sides, so 16x square is less than equal to 25. So x square is less than equal to 25 by 16. So you will get x square as xs less than equal to 5 by 4 and greater than equal to minus 5 by 4. Beta. If you take under root, so you will get two value 5 by 4 and minus 5 by 4. So minus 5 by 4 to 5 by 4. Okay, that was the value of fx. You can simply say that x belongs to minus 5 by 4 to pi by 4. Okay, now come to next question. Now the question is, write the domain of 1 upon log 1 minus x. Write the domain of 1 upon log 1 minus x. Now see the solution of that one. So what is the domain of log x? We know that the domain of log x is means log will always take a positive value. So that means that 1 minus x is always greater than equal to 0. We have uh, studied in the starting partner that log inside the log is always positive. So 1 minus x greater than equal to 0. So x minus 1, if you take minus common, is less than equal to 0. Now, if you add both sides 1, so you will get x less than 1. So you will get the value of x belongs to minus infinity to minus infinity to 1. Okay. And okay, wait. Log does not contain 0. So x less than 1 means minus infinity and 1, but it does not take 0 value. Okay, so we will take minus infinity to 0 and 0 to 1, but that was not included. So x belongs to minus infinity to 0 comma union 0 to 1. Okay, so that was important for your exam point of view. That was the most important question. So now next is, if fx is equal to log x, if fx is equal to log x, then find the value of then find the value of f2 plus f3 plus f4 upon log 24. Now see the solution. Fx is log x. Now take f2 as log 2 plus log 3 plus log 4 upon log 24. So we know that log m plus n, log m plus log n is equal to log m plus n. Wait, huh? Log m plus log n is equal to log m into n. Now apply that formula in the numerator. So you will get log 2 into 3 into 4 means 6 4 is 24 upon log 24. So log 24 upon log 24, which is equal to 1. Now come to next part. Next part is find the range of sin x minus cos x. Wait, huh? Next question is, find the range of find the range of cos x minus sin x. Okay, now see the solution. I have taught you earlier in the chapter of trigonometry that if the function is came as a sin theta minus b cos theta is equal to c. So what is the range? C square plus under root a square plus b square. Okay, that was its maximum value. And what is the minimum value? C square minus under root a square plus b square. If the function is came as a cos theta minus b sin theta equal to c. So in both the cases, the maximum value will be c square plus under root a square plus b square and c square minus under root a square plus b square. Question is cos theta minus sin theta. Nothing is given, so 0. You can take 0. So c is 0, a is 1, b is 1. So the maximum value will be 0 square plus under root 1 square plus 1 square. That means under root 2. And minimum value will be 0 square minus under root 1 square plus 1 square. So minus of root 2. So you can take the range as minus root 2 to root 2. So the range will equal to minus root 2 to root 2. Okay. Now come to the next part. Find the range of log mod 4 minus x square. Now we know that the domain of log x is contain only positive number and the range of log x is always real number. So the range of log 4 minus x square is always real number. Now come to the next part. Next question. Wait just a minute. Find the domain and range of fx is equal to x square minus 4 upon x minus 2. And the function is x square minus 4 upon x minus 2. A square minus b square is equal to a minus b or a plus b. So x minus 2, x plus 2 upon x minus 2. Now that term will be cancelled. So fx is equal to x plus 2. Okay, but that does not equal to its domain. You have to take any real number, but which is does not equal to 2. Because if you take 2, so it will become 1 upon 0, which is infinite. So that was not a real valued function. Okay. Now the next question is, if f is from a to b and ia, comma ib are identity function, Then show that IB of F is equal to F of IA. Now come to the solution part. IA means identity function. What do you mean by the identity function? Means which have the same domain and same range. So IA is from A to A and IB is from B to B and the F is from A to B. F is from A to B. Now first is F of IA. F of IA. We know that F is from F of IA. F of IA. You can simply say that F of IA means if F is from A to B and IA from A to A are two functions. So by definition of composition, so by definition of composition of functions, F of IA, F of IA is also a function from A to B. Okay. Similarly, F is from A to B and IB is from B to A, B to B, and IB is from B to B are are two functions, then IB of F is from A to B. Okay. So both F of IA and IB of F are from A to B. So which means that both the function are equal. So since IB of F from A to B, so let for A belongs to A, we have I of F IB of F of A. So IB of F of A means IB of FA. So we will get FA as value. Okay. Now, and if we take F of IA of A, which means equal to F of IA. So IA means which is equal to A. So FA. Okay. So both F of IA equal to I of FB. Sorry. F of IA or IB of F equal to F are equal. Okay. That was some means memorizing question. So you can remember all the step of that. Okay. Now come to the next chapter. That was your principle of mathematical induction. So the next chapter is your principle of mathematical induction. Principle of mathematical induction. Mathematical induction. Now, what is induction? Firstly, take what is the induction? Induction means a specific case to general case, or you can simply say that example to rule is considered as the induction method. Now suppose I am taking example that Vignesh is eating food. Vignesh eats food. Bhaskar eats food. Bhavna eat foods. Ayushi eats foods. So what are these? The first two are males and the last two are females. So what we conclude from it? That we can say that all human eats food. All human eats food. So that is known as the induction. Means firstly we have to take example, then after example we come to rule. So that was known as induction. Okay. So what do we have to do in this chapter? We have to take three steps. Firstly, we have to check any function Pn for one. Check for one. Okay. Check for n equal to one. Check for n equal to one. And the second step is we have to randomly take for n equal to k is true. Pn is true. Now third one, after taking n equal to k, so check for k plus 1. If for k plus 1 function is true, so that means the function is correct, means mathematically induced. So the function Pn k plus 1 Pn is true. Pn is true. So Pn is mathematically induced. Mathematically induced. Mathematically true. You can say the mathematically true. Okay. Now remember some terms here. The sum of n terms, the sum of n square terms, the sum of n cube terms. Okay. First is sum of n terms. So sum of n term is n plus 1 by 2. Now second, sum of n square terms. So sum of n square term is n plus 1, 2n plus 1 by 6. So n plus 1, 2n plus 1 by 6. And now the third one, sum of n cube terms. Wait, just a sum of n cube terms. So sum of n cube terms is equal to n plus 1 by 2 whole square. Okay. So firstly remember this formula. Now come to the main part. I am directly solving its question. So maybe I will have to take one more classes of that chapter. Now show that 49 to the power n plus 16 power n plus 16 to the power n minus 1 is divisible by 64, is divisible by 64 for all positive integer by mathematical induction. By mathematical induction. Now come to the first part. That was we have to take n equal to 1. Firstly, we have to prove it for n equal to 1. Let Pn will be the statement. Let Pn equal to 49 to the power n plus 16 to the power n minus 1. Now take P1 means put n equal to 1. So you will get 49 plus 16 minus 1, which is equal to 49 plus 65 is 65 minus 1 equal to 64. So 64 is divisible by 64, is divisible by 64. So for n equal to k, you have to take is true. So let for n equal to k, the statement is true. The statement is true. So pk equal to 49k plus 16k minus 1 is divisible by 64. Is divisible by 64 means we have to take 49k plus 16k minus 1 equal to 64 into t. Okay, that was your equation first. Okay, you have to take n for n equal to k, the statement is true. Now for n equal to k plus 1, for n equal to k plus 1, so p k plus 1 equal to 49 to the power k plus 1 plus 16 to the power k plus 1 minus 1. Okay, so we will take it as, I am writing once again the step. 49 to the power k plus 1 plus 16 k plus 1. Okay, wait, just a wait. Here is k is in multiply. K is in multiply. K is in multiply. K plus 1 minus 1. I have written wrong, huh? 16n. So 16n minus 1. Okay. So 16k plus 1 minus 1. So you can break it in 49k into 49 plus 16k plus 1 minus 1. Now from equation first, what we have taken that 49k plus 16k minus 1 equal to 64t. T means any number. So if this term will come right hand side, so 49 to the power k equal to 64t minus 16k plus 1. So in place of 49k, you can put this value. So 64t minus 16k plus 1 into 49 plus 16k plus 1 minus 1. Okay, now what we have to take, we can take it as 69, 40k minus 1, k plus 1. So 49t 49k plus is equal to 64t minus 1. So we have put in the equation first. So if you multiply, so you will get 49 into 64t minus 16 into 49 plus 1 into 49 plus 16k plus 16 minus 1. On solving, you will get 49 into 64t minus 16 into 49 plus 4k 49 49 plus 16 plus 15 means 31. So 9 and 1 10 0 1 balance. So 4 3 7 or 80. Okay. Now if you will take 16 common, so you will get 49 into 40 minus 49 plus 16 5 ja 80. 16 into 49 k also there. K also there. So 49k plus 5 k plus 5. Now if you will take 4 common, so you will get 64 into 14 t minus 49 by 4k plus 5 by 4 means 64 into any integer. Okay, that means pk plus 1 is also divisible by 64. That means pk plus 1 is also divisible by 64. Okay, that was your first question of principle of mathematical induction. Now come to next question. Now the last thing is n square plus n plus 1 equal to 4. So come to the next question. Using mathematical induction, using mathematical induction, using mathematical induction, prove the statement, prove the statement 1 cube plus 2 cube, 1 cube plus 2 cube plus 3 cube plus dot 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 n cube equal to n square n plus 1 whole square by 4 for all n belongs to n. N means a natural number. Now come to the solution. Let this series will be Pn. So Pn equal to 1 cube plus 2 cube plus 3 cube plus dot 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 n cube. So which is equal to n square or n plus 1 whole square by 4. Now take for n equal to 1. So for n equal to 1, for n equal to 1, n equal to 1, you have to take only one term in LHS. So only one term means n 1 cube. So 1 cube for n equal to 1, LHS will be 1 cube. 1 cube is equal to 1. And RHS will be, you have to put in place of n as 1. So 1 square plus into 1 plus 1 whole square by 2. So 1 square into 1 plus 1 whole square by 4. So 1 square into 2 square is 4 upon 4. So you will get answer as 1 square means 1. So for n equal to 1, Pn is true. Now check, now take for n equal to k, the function will be true. Okay. So for n equal to k, Pn will be true. Pn is true. For n equal to k, Pn is true. So 1 cube, 1 cube plus 2 cube plus 3 cube plus dot 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 n cube is equal to n, n plus 1, sorry, can take k in place of n, you have to take k now. So k plus 1 whole square by 4. That was equation first. Now for check for k plus 1. Okay. I have to check for k plus 1. Checking for k plus 1. So now add k plus 1. Add k plus 1 whole cube on both sides of equation first. On both sides of equation first. Now if you add both sides, so 1 cube plus 2 cube plus 3 cube plus dot 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 k cube plus k plus 1 whole cube is equal to k plus 1 whole square, k square also there, k square plus k plus 1 whole square by 4 plus k plus 1 whole cube. Okay. Now if I take k plus 1 whole square as common, so what I get? I get k square by 4 plus k plus 1. Now take the LCM. So you will get k plus 1 whole square into bracket. You have to take LCM as 4. So I am taking LCM as 4. So k square plus 4k plus 1. 4k plus 4. So this was became the formula of k plus 2 whole square. So k plus 1 whole square into k plus 2 whole square by 4. And here 1 cube plus 2 cube plus 3 cube plus dot 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 k plus 1 whole cube. That means it is true for, so Pn is also true for k plus 1. So by the principle of, by the principle of finite mathematical induction, of finite mathematical induction, Pn is true. Pn is true for all n belongs to n. Hence 1 cube plus 2 cube plus 3 cube plus dot 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 n cube is equal to n square, n plus 1 whole square by 4 for all n belongs to n is true. Okay. So that's all for today. So if you have doubt in any question, so you can send the question to sir or ma'am. They will forward me, or I will clear in the video session. Maybe this video will be the last video, or maybe one session I will also take in mathematics in 1 or 2 days. Okay. So that's all for today. Thank you, everyone.